Hi, my name is Josh and welcome to our group project on the Smart Forklift. We plan to produce a 3D printed prototype that features autonomous path tracking, obstacle recognition, an automated pickup algorithm, as well as return and drop-off commands. Our intention for this project is to provide industrial and commercial workplaces a safer alternative. Our aim is for the risk of workplace injuries to be removed by implementing an automated solution. This would also enable the business to maximize efficiency and streamline the entire logistics process.
Firstly, it will receive user input via Bluetooth on where the item is. It will track along these path lines drawn across the warehouse to get to that location and stabilized with a PID system. Once it reaches the aisle, it will execute a pickup maneuver by driving close to it in a way to pick it up and eventually return back using the same path route.
Essentially, our microcontroller is the brains of the smart forklift system. It controls the PCB that drives and steers the motor systems as well as operates the forklift. It also includes algorithms that resolve IR and ultrasonic sensors and calculate stable pathways, all via Bluetooth control.
The PCB contains an ESP32 which controls all components on the board and uses Bluetooth to exchange data with the PC. The board is divided into sections based on voltages and functions. The section labeled 5V_1 is responsible for powering the high torque steering servo. The 5V_2 section powers the low torque servo for the 2D visualization system. It also powers the various sensors such as the line and ultrasonic, and also a 3.3V regulator that supplies power to the ESP32 microcontroller. The lifting and steering motors are powered using a motor driver IC. A relay is used to dictate which of the motors are active. Sensor pins are placed at the edge of the PCB to make connections more convenient. This is the 2D visualization system designed in a program called processing. Each circle represents a 5 cm interval. The outer circle is 25 cm. Distances more than 25 cm will not be displayed on the graph. As seen in the diagram currently shown, the sensor managed to detect the can and the two boxes. However, angled surfaces can cause inaccurate readings. The code is also able to identify lines.
Using Fusion 360, we have modelled and are printing a vehicle of forklift properties. Our team modelled our rear differential off of your generic automotive vehicle, which will then motorise the rear wheels whilst being functional. The outside wheels need to spin the wheels forward, but also move freely at different speeds around corners and other instances where the rear wheels will move differently.
The inner internal gears allow this free movement, while the outer internal gears are connected to a pinion connected to the electric motor. Due to the steering at the vehicle's rear, the axle needed to rotate freely and the wheels to turn. Universal joints allowed the steering system to turn the wheels while still being motorized. Using a wide range of gears, we put together a mechanism capable of lifting different objects for different commercial uses. A series of different mounts were modeled to put these various components together so that it can work as a functional forklift with the ability to park automatically.